When 2800 hours rolls around, it's time to tighten up some things on your EMD. You're also going to need to check a few things to make sure they're doing what they're supposed to be doing. By this time, you're probably an expert on what to do for the 700-hour tasks, and you've already been through the 1400-hour tasks. Well, the 2800-hour maintenance includes everything you did for the 700 and 1400-hour tasks, plus a couple of little extras. So, let's go back over the 700 and 1400-hour tasks before we get started on the 2800-hour tasks. You'll change the oil in the governor, clean the fuel strainers, and change the fuel filters, check the engine coolant inhibitor concentration, check the working order of the crankcase pressure detector, change the lube oil filters, clean the oil strainers, check and clean the turbocharger oil filter and soakback filter check valves, check and clean the soakback filter relief and bypass valves, change the engine air filters, clean the adductor tube, clean the heat exchanger if the engine temperature is too high, and inspect the heat exchanger zinc anodes. If you're not sure about all this or need to go back over any of these procedures, just go back to the program's 700-hour maintenance tasks or 1400-hour maintenance tasks. We've laid out what needs to be done at those times. So now, let's take a look at what else you do at 2800 hours. Most of what you'll need to do is tighten bolts and check a few things. Well, here, let's take a look at what we need to do. Since your EMD has been running for so long, some of the bolts on the engine might have loosened up a little. For some of these bolts, this could really get dangerous. Take the exhaust manifold, for example. If the manifold to crankcase bolts aren't torqued down to what they should be, you could get an exhaust gas leak into the engine room. That's not a good situation for those of us that have to breathe the air around here. So you'll need to get out your manifold torque tool set. You should be able to retorque all of the bolts without having to take off the manifold head shields. You'll be able to reach all of the outside bolts by using the short adapter and extension of your tool set. But in order to get at the center bolts, you're going to need to use the long adapter. All of the bolts need to be torqued down to 130 foot-pounds. Just tighten down the bolts until the dial shows 130 foot-pounds. That is, if you're using the short adapter. Now, when you're using the long adapter, you're going to have to adjust this reading a little. In order for you to get the 130 foot-pounds of required torque when using the long adapter, the dial should read 76 foot-pounds. Now on to the other bolts. You'll need to torque down the turbocharger to air duct bolts to 65 foot-pounds. Again, these bolts can work themselves loose from the vibration of the engine, so you'll need to go to each one of the bolts and retorque them. The air duct to crankcase bolts also need to be torqued down to 65 foot-pounds. If you lose the connection here, you could lose air that flows through the system. And finally, torque down the aftercooler to air duct bolts to 45 foot-pounds. As with the other two sets of air duct bolts, if you lose the connection here, you're going to lose that pressurized air which is supplied for the combustion. Next is the turbocharger exhaust inlet screen. It's located back here between the turbocharger and the rear section of the exhaust manifold. What you need to do here is take off the screen, clean it, and then check it over for any cracks. What this screen is there to do is to protect the turbocharger. It catches foreign material that might get into the exhaust manifold, like broken piston rings and small pieces of a broken exhaust valve. If the screen weren't there, this stuff could slip into the turbocharger and it could do some real damage to the turbine blades. When you take the screen out, if it does have any broken pieces of a piston ring or an exhaust valve, you're going to need to do a couple of things. First off, check down in the manifold. If there are pieces in the screen, there's a chance that some pieces got down into the manifold. The other thing to check is the power packs. Find out which one of them has the broken exhaust valve or piston ring and replace it. Now, one thing to be careful of when dealing with this screen is that it can plug up pretty easily with carbon and water treatment residue. When you pull it out, if it's pretty well plugged, get it clean. But remember that this thing's gotten this bad since the last 2800-hour maintenance. It could be that you need to clean it up a little more often because a plugged screen causes the engine and turbocharger to have to work harder to put out the same amount of work. If the screen is clogged, you can clean it with a stiff wire brush. After you've cleaned it, you need to check it over real good for any cracks. If you find any, you're going to have to replace that screen. It's not going to be any good to you if it's cracked. Also, after cleaning, you'll need to find out what caused it to become clogged. It won't do you any good just to put the screen back without finding out why it clogged up. Most of the time, it's caused by what we call souping. This is when the engine lube oil gets past the oil control rings and the pistons and doesn't burn off. This usually occurs when the engine is operating under a light load for a long period of time. So if you're running your engine under a light load a lot, you'll want to keep a close eye on the screen to make sure it stays clean. Now that's if it's clogged with lube oil. But if the screen's plugged with water treatment residue, it's probably because of a cooling system leak somewhere, and it's more than likely coming from one of the cylinder heads. The way you can check this is by taking a light and a mirror and looking in the exhaust manifold to see which cylinder the water treatment is coming from. Once you've found the leak, all you need to do is get in there and fix it. The last thing you'll need to do before reinstalling the screen is to coat the threads of the bolts with some sort of high-temperature lubricant, and then torque all of the bolts down to 80 foot-pounds. Another thing that you're going to need to check is the overspeed trip mechanism. It's there as a kind of safety valve for the engine. If the engine speed gets too high, the trip release mechanism steps in and cuts off the injection of fuel to the cylinders, so the engine shuts down. This thing's part of the right bank front camshaft counterweight. It's made up of a flyweight that's held by an adjustable tension spring. The way it works is when the speed of the engine gets over the maximum limit, the tension of the spring is overcome by the centrifugal force acting on the flyweight, which causes the flyweight to move out and hit the trip lever. Then, the actuating spring, acting through all of its connecting links, rotates the trip shaft. This causes the trip shaft cams to contact and lift the injector rocker arm pawls, and that prevents full injector rocker arm roller contact on its cam, which in turn prevents fuel injection, and that stops the engine. You're going to need to check this thing to make sure it's tripping at the right engine speed. So what you'll need to do is set your engine at idle speed and manually raise the engine's RPM from idle to trip over a 20 to 30 second interval. To get an accurate RPM reading, you can get a handheld tachometer, which you can put in at the camphor opening in the end of the cam or at the governor drive. If the overspeed mechanism doesn't trip at the right speed, then you're going to have to adjust it. To do this, shut the engine down and take off the round cover from the right side of the overspeed trip housing. Loosen the lock nut at the end of the flyweight spring and turn the adjusting nut to increase or decrease the spring tension. If the overspeed mechanism is tripping in too soon, then you're going to have to increase the spring tension so that it takes a higher engine speed to trip it. And obviously, you're going to have to decrease the spring tension if the mechanism is tripping in too late. Once you have the adjusting nut where you want it, you'll need to tighten down the lock nut to hold it there. Now, you're going to need to test it again to make sure it's tripping at the right speed. Crank the engine over and get it running at idle speed. Then again, manually increase the engine speed. The mechanism should trip between 20 and 30 seconds. It'll probably take you a couple of times of getting back in there and readjusting the adjustment nut before you get the mechanism to trip at the right speed. Once the overspeed mechanism is set at the right speed, put the cover back on the overspeed trip housing and tighten the bolts. All of this is for checking at what speed the overspeed trip mechanism trips in. If all you want to do is check the RPMs of your engine, take your handheld tachometer and put it into the governor drive housing. The reading you get should be very accurate. If your engine has a mounted electrical tachometer generator, it'll give you an accurate reading without your handheld tach. The last thing that needs to be done is to lubricate the governor synchronizing motor bearings and the moving parts of the governor to injector control shaft, which are on the outside of the engine. All you're going to need at each one of these points is a couple of drops of oil. That's all there is to the 2,800-hour maintenance tasks. Now let's go back over everything that you'll need to do. First, you're going to have to do all the stuff in the 700-hour maintenance tasks. Change the governor oil, clean the fuel strainers, and change the fuel filters. Check the engine coolant inhibitor concentration, and finally, check the working order of the crankcase pressure detector. Once those are done, you do all the tasks in the 1400-hour maintenance. Change all the lube oil filters, clean the oil strainers, check and clean the turbocharger oil filter and soakback filter check valves. Check and clean the soakback filter relief and bypass valves. Change the engine air filters. Clean the adductor tube. Clean the heat exchanger if the engine temperature is too high. And finally, inspect the heat exchanger zinc electrodes. After that, you'll need to do the things we've just covered in the 2800-hour tasks. Retorque the exhaust manifold to crankcase bolts, the turbocharger to air duct bolts, the aftercooler to air duct bolts, and the air duct to crankcase bolts. Then, clean and check the turbocharger exhaust inlet screen, check the overspeed trip setting, and then lubricate the governor synchronizing motor bearings and the governor linkage moving parts. Once you've done all of these tasks, that engine of yours should be in pretty good shape. All it's going to take from you is to keep track of when to do your periodic maintenance and when it's time to get in there and do a good job of it. If you just do these two things, that engine of yours should last you a long time.